So what we want to know is the probability that she knew the answer if she got the question correct. So what we really want to know is the probability that she didn't guess, conditional that she got it correct. Okay, so that is what our final answer should be. So let's go ahead and write down the things that we do know. What we do know is the probability that she guesses is 20%, which means that the probability she doesn't guess is equal to 1 minus the probability that she did guess, which is 0.8. Then the other thing that we know is the probability that she gets it correct, conditional that she guesses, is 0.25. And that's because we have 4 multiple choice questions and it's done at random. The other thing we know is the probability that she gets it correct, conditional on not guessing, is equal to 1. And that's because she knows the answer, she can answer it correctly, and there's no guessing involved. So this is all the information that we do know simply from the wording of the example. So let's go ahead and think about what it is we need to solve in order to get to where we want to be. So as we mentioned, we want to know the probability, let's keep that slightly more legible, the probability that she didn't guess, or she knew the answer, conditional she got it correct. Well, we can use what we know in terms of equations, that this is equal to the probability that she didn't guess and she got it correct, divided by the probability she got it correct. So an application of Bayes' law. Now let's focus on the bottom part. Well, the probability she got it correct is equal to the probability she got it correct and she didn't guess, plus the probability she got it correct and she did guess. So that is the mutually exclusive options of being able to get it correct, either from guessing or from not guessing. Now the top, we can rewrite the top using Bayes' law, is the probability that she got it correct, conditional on not guessing, times the probability of not guessing. So now that when we look at the information we know, well, it looks like we know the probability that didn't guess is right here. The probability conditional getting it correct, given that you guessed, is right here. So now we just need to think about this denominator, and we don't quite have these terminologies. So let's go ahead and use Bayes' law one more time to write out this denominator. So this is equal to, let's keep our numerator the same since we know what those numbers are. Correct, given that you didn't guess, times the probability that you didn't guess. And now this denominator, let's think of it this way, is we can now apply Bayes' law to say this is the probability, or this term right here, we can write as the probability that you got it correct, correct, conditional on not guessing, times the probability that you didn't guess. So that is just the application of Bayes' law. Plus, now let's go ahead and use this one with the application of Bayes' law, is the probability of correct given that you guessed times the probability that you guessed. And now we can look to see, we know all the different components from this. So this is just continual applications of Bayes' law, really, to change this initial equation we had right here into something that we have all the different parts for. So now that we have those parts, let's go ahead and plug and chug. So the probability they get it correct given they didn't guess is 1 times the probability you didn't guess, which is 0.8, divided by, And there again, we get that 1 times 0.8 plus the probability to get it correct, given that you guess, is 0.25 times the probability that you guessed, which is 0.2. And so we just plug that into a calculator, and that is equal to 0.9412. And so that there is our final answer. Now you might say, well, isn't there another way to go about doing this? And the answer is yes, there is. So let's look over here at another way. So maybe another thing we could think about, well, what we might want to think about is 1 minus the probability that they guessed, conditional they got it correct. And if this is the case, then we can then apply similar type applications of Bayes' law. So this is probability of G and C over the probability of getting it correct. And then we can then one more time do an application of Bayes' law to reverse that. 1 minus the probability of C condition on G times the probability of G all over the probability of getting it correct. And now we know the bottom, 1 minus P of C condition on G, probability of G, over, and this is where we get our probability of C and not G, plus the probability of C and G. And now we can plug in and plug and chug so that we get 1 minus, and here we get 0.25 times 0.2 divided by 1 times 0.8 plus 0.25 times 0.2. And so this is equal to 1 minus 0.0588, which is the same answer that we had using the other method. So we can use either of these methods to calculate the probability that she knew the answer conditional